Here are some tips for the post-lab assignment for Lab 6 buffer solutions. Question number 1, all you have to do is report the pH values of each of those 4 solutions. There's nothing else you need to do there. Questions 2 and 3 both pertain to part 2. In this first data table, you're going to be reporting the total volume of the buffer. That is just the combined volumes of the 2 solutions that you mixed together. So all you have to do here is just add these up. And then in this, the last 2 columns, you're going to be calculating the molarity of the acetic acid and the molarity of the acetate in the buffer. To do this, you're going to use the M1V1 equals M2V2 equation. For your CH3COOH calculations, your M1 is the initial molarity of that acetic acid solution. Here's your V1. This is going to be your V2, whatever the new combined volume is, 50 milliliters in this case, that's going to be your V2, and then you'll just use that to solve for M2, the new molarity. For the CH3COO minus, there's your M1, 0.1 molar. Here is your V1, 25 milliliters, and this is also your V2, so both of these components have the same total volume, and you'll be calculating for M2 again. You are going to copy these molarities down into the next data table. So you'll just copy those down, and then you'll report here the pH that you recorded from the lab, from the experiment. Then once you get that, you're going to be able to calculate the pKa using the Henderson-Hasselbalch equation. pH equals pKa plus the log of the concentration of the base over the concentration of the acid. This is our acid and this is our base. So we know the concentration of the base, we know the concentration of the acid, we know the pH, and so we have everything we need to solve for pKa. Once we get pKa solved, we're going to calculate for Ka. Ka is just simply 10 to the negative pKa. That's going to give you this number right here. And these should all be pretty similar. Then on question number 4, this is a space for you to do your work to show the calculation that you needed to do for part 3, how to prepare a pH 5 buffer that is approximately 5 milliliters or 50 milliliters. For this, you're going to use the Henderson-Hasselbalch equation again. pH equals pKa plus the log of the concentration of the base over the acid. Now, you're not going to be able to completely solve this Henderson-Hasselbalch equation because you just don't have enough information. But you do know that your pH, you want the pH to be 5, so you're going to plug that in for that. And you're going to use the pKa of acetic acid, not the one that you calculated over here, but the true pKa of acetic acid. You'll look that up. And then all that you're going to be able to do is solve for the ratio of the base to the acid. So you're going to be solving for the ratio, not the ration, of the concentration of base over acid. You're not going to be able to solve for the base individually or for the acid. So let's just say that you end up with the base to the acid being equal to 1. That would mean that you needed a 1-to-1 ratio of the base and the acid, and you would want to mix them in equal volumes. Let's say that you ended up with a ratio of 3. This would mean you would need 3 times the base to have a concentration 3 times greater than the acid. So whatever this number is here that you get, you're going to use that. Let's just say that it's 1. And you're going to say that you need a 1-to-1 ratio of the base and the acid with a total volume of 50 milliliters, roughly 50 milliliters. And so you would accomplish that by mixing 25 milliliters of each. That would give you a 1-to-1 ratio with a total volume of 50. So whatever this ends up being, if this ends up being a 2-to-1 ratio with a total volume of 50, then maybe you would say you would want something like 30 to 15. That would give you approximately 50, and that would be a 2-to-1 ratio, 30 milliliters to 15 milliliters. Once you have successfully made your buffer, you are then going to calculate your percent error. That is going to be done by taking your pH, whatever it is that you get, subtracting 5, and this needs to be an absolute value. It might be positive, might be negative. Divide by 5, and then multiply it by 100. That's going to give you your percent error.